Let's start with a wild thought experiment. What if the most basic, fundamental force in the entire universe, the one we never ever think about, just stopped? Today, we're going to find out. What if gravity just vanished? I mean, what if the very thing holding you in your seat right now just switched off? Not for a day, not for an hour, just for one single second. We're going to break down exactly what would happen, from the atoms inside your body all the way out to the biggest things in the cosmos. It's so easy to forget that gravity is the silent architect of our entire reality. It's not just about keeping our feet on the ground, it literally holds our planet together and keeps the sun from blowing itself to bits. So what happens if we pull that plug? All right, first things first, let's look at what would happen to you, personally, in that 1 second where gravity takes a vacation. The effects would be immediate, and frankly, they'd be pretty weird. The very first thing you'd notice is everything becoming weightless. You, your chair, your phone, everything not physically bolted down would start to float. But it gets a lot worse, and fast. Your blood would stop circulating properly, basically starving your brain of oxygen. Some physicists even argue that without gravity holding them together, the atoms that make up your body could just fly apart. But here's where it gets really, really violent. You wouldn't just gently float up. See, the Earth is spinning at hundreds of miles an hour, and gravity is the only thing tethering you to its surface. Without that connection, your inertia takes over, and you'd be launched sideways at an incredible speed. So yeah, that's a much, much bigger problem than just floating. And then, just as suddenly as it all began, it's over. Bam. Gravity switches back on. Everything that was floating, people, cars, furniture, huge amounts of water from the oceans, is now yanked back down with a vengeance. The result would just be a chaotic, worldwide crash as everything smashes back to Earth. As bad as all that sounds for us on the surface, believe it or not, it's nothing compared to what would happen to the planet itself. So let's zoom out and look at the truly catastrophic global scale. You see, the Earth is in this really delicate balance. The moment gravity disappears, that immense inward pressure is gone. The molten core, which is under unimaginable pressure, would instantly erupt outwards, shattering the tectonic plates from below. You're talking about a planet-wide earthquake, and literally every volcano erupting all at once. Even when gravity returned, the momentum would be unstoppable. And our atmosphere? The only reason we have air to breathe is because gravity holds it down. For that 1 second, it would start to rapidly expand and just boil away into space. Now, gravity's return would pull most of it back, sure, but the violent rush of air returning to the surface would create storms beyond anything we can imagine. The damage would already be done. But the biggest question of all, the real heavyweight champion of this thought experiment, is our sun. What happens when you remove the force that holds a star together? This kicked off a pretty intense debate in the source material, with two totally different answers. The first, and maybe the most intuitive answer, is just pure catastrophe. As one person put it so beautifully, well, the sun would explode, so there's that. The thinking is that the sun's immense explosive energy would be instantly unleashed. To get why, you have to picture the sun as being in a constant, epic tug of war with itself. The nuclear fusion at its core creates this colossal outward push, like a never-ending explosion. At the exact same time, the sun's own massive gravity is pulling everything inward, containing that blast. It's this perfect, violent balance. Removing gravity is like cutting one side of that rope. But then you get the counter-argument, and it all hinges on one simple fact. A microsecond or even a whole second is an unbelievably short amount of time when you're dealing with something as massive as the sun. The key word here is inertia. So let's break it down. You've got Team Explosion on one side. They argue that without gravity's containment, the sun bursts outwards. Then when gravity snaps back, all that matter comes crashing back in, creating a shockwave, kind of like a supernova. But then you have Team Inertia, and they're saying, hold on. The sun has so much mass. Inertia means that mass can't just accelerate and move that far in such a tiny amount of time. The expansion would be minuscule, and the sun would pretty much just settle back to normal. So which is it? Well, someone actually did the math, and the results are fascinating. In just 1 microsecond, the expansion from all that nuclear power would be a tiny, tiny fraction of a nanometer. The surface would move about 2 millimeters from its own rotation, and even the massive internal pressure would only cause the sun to expand by about 30 centimeters. On a star that's almost 1.5 million kilometers across, that is
Absolutely nothing. Team inertia wins this one, hands down.
Okay, so our sun survives a 1 second blip. But what about the rest of the universe? What happens to objects with even more mass and even more extreme gravity?
Well, on the cosmic scale, it's a mixed bag. Much bigger stars would definitely see a more significant expansion. Planets in orbit would fly off in a straight line for 1 second, shifting their orbits a tiny bit, but probably not catastrophically. And as for huge structures like galaxies, they're so vast that a 1 second pause would be completely, totally unnoticeable. But, and this is a big but, for the densest, most extreme objects in the universe, like neutron stars and black holes, it's a whole different story. Their internal pressures are almost beyond comprehension, held in check only by the most powerful gravity imaginable. You remove that gravity for even an instant, and they would erupt in a tremendous space explosion, unleashing an amount of energy that's hard to even wrap your head around. So, after all that chaos and cosmic destruction, it's time to come back down to Earth. Because as fun as this is to think about, the laws of physics as we understand them say it could never, ever actually happen. The simple reality is gravity isn't a light switch you can just flip on and off. It's a fundamental property of mass and energy. To turn off gravity, you'd have to make every single thing in the universe lose all of its mass and energy. The two are just completely inextricably linked. In fact, Einstein totally reframed how we see this. Gravity isn't really a force pulling things together at all. It's a property of the universe itself. Think of space-time as a giant stretchy fabric. A massive object like the sun creates a big dip in that fabric. Planets aren't being pulled by the sun, they're just rolling along the curve that it creates in space-time. Gravity simply emerges from that geometry. And that leaves us with one last big question. If a force as powerful and constant as gravity is really just a feature of the universe's geometry, what other parts of our reality are way more fragile and way weirder than they appear? Thanks for diving into this with us.